They're all right angles. They all measure 90 degrees. Even more beautifully, since this angle and that angle are 90 degrees, they're congruent. I've got two sides and the angle in between them, so I just proved side, angle, side. Two sides, and the angle in between them match up. I just proved that those two triangles are congruent. All right, let's go to the bottom. Number 2. If JKLM is a parallelogram, how are triangle JIM and triangle LIK congruent? If JKLM is a parallelogram, how are triangle JIM and triangle LIK congruent? All right. Now, unlike the last one, we're talking about smaller triangles. We're talking here about this triangle, and we're talking here about this triangle. Not a whole half of the shape, but a quarter of the shape. Okay? So, proving congruent. Give me some obvious statements about a parallelogram. What do we know about the opposite sides of a parallelogram? What? The lines are the same. The lines are congruent. Opposite sides are congruent. So we know that this matches up with that. As far as that and that, we don't really care because those aren't part of the triangles that we're trying to make. Okay. Give me. Thought that would be that one. Okay. What else is true about the opposite sides of a parallelogram other than the fact that they're congruent?
Their angles are congruent.
Huh?
Their angles are congruent.
Yes, they are congruent. The angles are congruent because the opposite sides are what? Good. The opposite sides are parallel. Right? This side is parallel to that side. Notice then that this and this would be a transversal. Remember, the transversal is the line that cuts across two parallel lines. Right? They make a certain type of angle called alternate interior angles. Remember, alternate interior angles say that on opposite sides of the transversal and between the parallel lines, that those angles would be congruent. So I can prove that that's the same as that by that. I can prove that that is the same as that. And now I've proved everything I needed to prove. I've got two angles and the side in between them. That's angle, side, angle. All right, example 3. If AB is congruent to EF and AC is parallel to DF, how are triangle ABE and triangle FEB congruent? If AB is congruent to EF and AC is parallel to DF, how are triangle ABE and FEB congruent? Okay. First thing I tell you is that AB is the same as EF. Well, that's good. They also tell you that AC, that line, is parallel to DF. That line. That might come in handy. Now, the thing that always makes people laugh about math is that mathematicians have to prove everything. All right. One of the things you're going to have to use here is called the reflexive property. that's bad. Reflexive property says that a line, or anything, could be anything, it could be a line, segment, array, a line is congruent to itself. No, I didn't say that wrong. The reflexive property says that a line is congruent to itself. So if I have this here and I want to say it's the exact same as itself, I have to say that's the reflexive property. Right. So, why does that come in handy? I can say that BE, this thing here, is reflexive. Right? By the reflexive property congruent to itself. BE is the same thing as BE. Alright, so I've got two sides. So somehow I've either got to prove that this side is the same as this side, or that that angle is the same as that angle. Now, there's no real way for me to prove that those two sides are congruent unless I can prove that this is a parallelogram, which is going to be hard to do. So, my next best thing then is to go for the angle. Is there a way I can say that this angle is the same as that angle? Nick?
Yeah.
Yes. What type of angles are they? They're between parallel lines, so would that make them interior or exterior, Nick?
Exterior. Interior.
They're interior. What's the word that goes before interior?
Entire.
Begins with an A. A-L.
Alternate.
Alternate. Good. They're alternate interior angles. So this is the same as this because they're between the parallel lines and on opposite sides of that transversal. So I've got two sides and an angle between them. I just proved side, angle, side. All right. Now, the nice thing about triangles